blinded me with science. Science. I can smell the chemicals. Science.
Hello, everybody. Hello, everybody. Welcome. Welcome to Comics Curing Cancer with your host, Matthew Murtha.
All right. You guys ready to talk science? Woo! Welcome to our third episode of Comics Curing Cancer. As always, this is a science talk show where we hope to bridge the gap between researchers and the general public through the use of comedy. So for those of you who don't know, this is being recorded live for podcasts and radio. So for all of our listeners out there and across the world, and we probably have, I think, roughly 10 million radio listeners. This is being recorded live in front of a studio audience of, I'd say, I don't know, maybe 5,000 people. That's right. Wait, make that 5,020 because the Swedish Olympic beach volleyball team just walked in the door. My God, are they gorgeous? Jesus. Put some clothes on. No, you don't have any clothes? All right, well, sit in the front. So let's begin. I'd like to bring on my co-host for the night, Miss Hannah Becker.
Is this on? Yeah, hey, what's up?
Oh, it's on.
Oh, it's on.
Welcome,
It's
Hannah
on.
Becker. How have you
Hi,
been?
I've been good.
Yep.
Yeah. How about you?
I've been pretty good.
Yeah?
So I hear that you used to actually be interested in science.
I still am, but I was quite the science math nerd back in high school.
What
yeah,
happened?
I was.
You used to be interested.
Well, I got to college, and I thought, oh yeah, maybe I'll do like calculus, maybe I'll do physics, I'll do that kind of stuff. And then I would see all my friends, like my science friends, studying all night. I'd like walk into the dining hall like 2 a.m, and they'd be there studying super hard. And I was just like,
I'm
I'd
gonna go get
rather-
high.
Yeah, I'd rather go get high and just have fun. Like that's. So I became a Spanish major. It was great. It was a great time. Got to like read weird books and just like it was fun.
I remember when I was an undergrad, I was double majoring in molecular biology and biochemistry. And the thing about it is that I went to school in Florida, right? So everybody else at the school was beautiful and tanned and like happy. And I was sickly and pale.
You were a
and
mole person.
Yeah, it was not a good look.
Yeah, should have been a Spanish major.
Yeah, that would have been helpful here in Spain.
Yeah, what would have been?
You want to do some comedy news and science?
Yeah, let's do some comedy news and science.
And we begin. China's decommissioned Tiangong space station will likely fall to Earth later this year. Launched in 2001, the small prototype space station was abandoned in 2013 at the end of its lifespan. NASA says its descent is a surprise and is uncontrolled. However, representatives of Chinese state media say that it was completely planned and totally expected.
Now North Korea is claiming credit for the station's demise, reporting that they shot it down using guns mounted on kites. Donald Trump also reportedly was intending to build a hotel on the station and now is blaming Hillary Clinton for the descent. Now he's saying that he didn't want to build it anyway in the first place. Stupid.
No politics, huh?
No?
Yeah. No, that's how you can tell it's like a research-heavy crowd. They just say, stick with the science. All right. Up next.
Yes, genetic testing of a tortoise population in the Galapagos Islands revealed that a single tortoise named Diego is responsible for fathering over 40% of the island's population. His sexual prowess single-handedly saved his species from extinction.
All right, so I find that pretty ironic because when I have sex single-handedly, I don't make any offspring at all.
Yeah. Scientists said that Diego was shy at first when he moved from the San Diego Zoo to the captive breeding program, but has since really come out of his shell. But
Dad humor. Come on.
now he mostly comes into other tortoises' shells.
Boom! That's ironically how Diego comes.
Super Diego.
Tortoises have the best orgasms. Moving on. A Swedish engineering firm added their own personal touch to the new self-driving car technology. They've installed an LED screen onto the front of cars that smiles at pedestrians to let the pedestrians know it's okay to cross in front of the car.
Researchers said that they needed self-driving cars to appeal to pedestrians and make something that felt familiar and created trust. Early plans involving a nondescript white van that automatically distributed candy and puppies was scrapped because of unintended consequences.
Sounds fine to me. I think I bet future models will actually be programmed to give the middle finger to people that cut you off, and then will wink at topless convertibles.
That's okay.
Too many scientists in the crowd tonight. What's
I
a
don't know
car?
about cars. What's a convertible? What's convertibles here?
What's topless?
Wow.
New research. This is a great one, and this is true. New research shows that howler monkeys with smaller testicles actually yell louder than their more well-endowed brethren.
Ah, so that explains all of Donald Trump shouting.
See how we set that up before? You're welcome. No, there are many theories as why this could be true. Scientists, of course, believe that by developing a larger vocal organ, they don't need as large of a sexual organ. You know, then again, there are those who believe in traditional masculinity, and they don't think that these small nutted monkeys are actually screaming any louder, but rather in a really high pitch.
Women think that they scream louder because they can't afford sports cars or convertibles.
Men believe that it doesn't actually matter how loud you are, it's what you say.
Are you still talking about the monkeys, or it's getting a little personal over here, Matt?
Speaking of size, astronomers recently discovered that the Milky Way galaxy is actually 4% larger than we had previously thought.
So our lives are also 4% more insignificant than we previously thought.
Maybe yours. I like to think that perhaps everything in the universe grew by 4%. Yeah?
Yeah, as we know, the universe is always expanding, just like Matt's ego.
And just like the universe, your head is a giant expanse of empty space.
Aww. Save the roast for later, Matt. People like me. They don't want you to be mean to me.
apparently.
It's
Man.
fine. I don't mind. It's okay.
Well,
go ahead.
I'm sorry. All right. Lastly, we have news from MIT that Leonard Garante, the head of MIT's Aging Center, is now developed a company that sells a pill promising extended life. Yeah. They claim that this pill will be the fountain of youth and will help you live forever.
Is it a drug called not doing any other drug?
No. Unfortunately. Apparently, though, it's a combination of other FDA-approved drugs, making this claim smell strongly of a money grab. However, despite their claims that the pill will extend your life, it's clear that this is not intended for researchers or other nerds, because in order to extend your life, you have to have a life to begin with. I'm just going to offend everyone tonight.
So, that's our comedy news and science for this week. Yay! Comedy news and science. It's a great jingle, right, guys?
It's a
It's
fantastic
a great jingle. Good job, Carlos.
Okay. So, tonight's topic will be cancer biology, yeah? And I was kind of inspired by that last news article that promises immortality. And it makes me kind of wonder about how to actually think about immortality. Because you have a person, yeah? And when they die, it's usually because of organ failure, yeah? However, a person is comprised of many millions or trillions of cells. I don't remember where the number is actually at. And so you can think of one organ's failure as actually as the death of some of its component cells. And then a cell itself is considered alive until it dies, and usually it dies because of internal organ failure as well. This is all well and good, and so while that pill is probably a load of shit, which is probably the only time you can say something that comes out of MIT, it does make you think of what we do have here that is considered immortal. And the best example are immortalized cancer cell lines. And so the most famous of these is something we call the HeLa cells. Who here knows of HeLa cells? Let me hear you, all 5,000 people. That's right. So HeLa got its time in the spotlight just recently by a book from, I don't remember the lovely lady's name. Anybody know? The Immortal Life of Henrietta Lacks. Anybody know the author? No. By the lovely Rebecca Skloot.
Yes, Rebecca Skloot.
All right, so Rebecca Skloot wrote a book that describes how these cells were first derived in 1951 from a lady named Henrietta Lacks. Yeah, and they've since become the most popular cell type used in the world. And it's kind of astounding because if you weighed all of the HeLa cells that have ever been made, it'd come out to being, I think, 3 trillion tons. These cells, yeah, you can correct me later. But think about it. These cells, since 1951, have been like the premier cellular model for cancer. They're used worldwide, and every day they're multiplying, dividing, I think, once roughly every 26 hours or so. I'd say 29. Yeah. So these cells, they continue on forever, and they really give you a new definition of what it means to be immortal. And it's not necessarily one individual cell that lives forever, but rather something that propagates itself throughout time. Now, I only want to bring this up because I got a juicy bit of gossip for it, and this being a very serious show, I think it's the perfect platform. So when I lived in New York, I dated a dancer, yeah? And she was working in this theater company, and they brought on a consultant with this guy named, I think it's Dave. And turns out that he had dated Rebecca Skloot just before the book came out, yeah? He broke up with her, and then she goes and writes this bestseller. The amazing thing, though, is that before he dated her, he dated this woman named Elizabeth Gilbert. Now, if you don't know that, what she's done, Elizabeth Gilbert, after breaking up with Dave, went on to write a book called Eat, Pray, Love. This book was made into a movie, and Dave's character was played by James Franco. Now, my girlfriend is now working with him, yeah, was at the time, and so I got a little bit threatened, as you do, because, he obviously has the Midas touch. So I deeply considered changing my sexuality just to get a book deal. Anyway, I think it's good. But tonight we're going to be talking about colorectal cancer cells, which obviously are the shittiest type of cancer you can have. And with that, I'd like to bring our first guest up, or tonight's guest. Oh. All right, so tonight's guest is Francisco Barriga.
Good
See?
accent.
He did his undergrad in Chile, his PhD at University of
Pompeu Fabra.
where he's currently a postdoc. Let's give him a proper welcome.
So, first of all, thank you for having me. I'm a big fan of the show, episode number 3.
Woo!
Yeah, and keeping it strong.
Third time's the charm, they
Yes.
always say.
exactly. So,
So I like to begin with like some nice, easy questions, both to make our guests comfortable and then so that you guys can connect with them, you know, as a human being. So just to start off with, what is exactly the rate constant for the dissociation of retinyldehyde from the rhodopsin A protein?
10 to the minus 8.
I feel like I know you like my brother. No, so where are you from? How did you get into science?
So I was born in the U.S. and then my family moved to Chile. Essentially, I got into science because my dad is a pediatric oncologist, which is fancy talk for a doctor who treats children with cancer. This cancer is usually in the form of leukemias and lymphomas, and growing up, seeing this as an actual issue, I decided, well, maybe I can put my efforts into solving this. At the exact same moment I said that, I realized I will never be able to treat a person, but maybe I can treat a disease. So then I just decided, well, I'll study biochemistry and get things going, trying to understand why are we not able to get rid of this disease. Yeah, pretty much that.
That's pretty inspiring.
Very inspiring.
I got into science because I was good at it.
Well, that also helped. I was shitty at arts, so yeah.
Yeah, I was not an athlete.
We can tell.
Man. So how do you All right, now I'm going to flex throughout the show. So how do you feel about being a scientist?
It's a great question. I have no idea how to feel. So I take it as a normal job, but then when you talk to people out there, you realize they really don't know any scientists, except this crowd, which is like filled with all the researchers in Barcelona.
You can tell because they're all beautiful.
Yeah, this is the classic trait of science.
I think I just winked at your wife. I'm sorry.
Well, I do have a black belt in Jiu-Jitsu, so we can talk about that later. So how do I feel about being a scientist? I think it's a very rewarding job in the long run. So the day-to-day basis is very frustrating. You're dealing with unknowns, and usually you get kicked in your ass. Every 100 ideas you have, 99 are wrong. Maybe that one works out. And then you also realize that I can dress as a teenager for the rest of my life. I have no real schedules, which also means no real vacations, but that's okay. And you're working with your mind, which is something very unique. You have to be creative. You want to stay on topic and like really pushing forward the field. So overall, I really like science and like being a scientist, although the years of study pay ratio is not as it should be, but hey, well.
Yeah, I always found that particularly amazing because scientists and researchers, they're supposed to be the smartest people ever, right? They're the cream of the crop. And yet we get paid shit for working the hardest, yeah? And so how smart can we really be? Every time, like, our advisors when we're in graduate school are like, oh, no, this is going to be worth it. We just need you to work 16 hours a day.
Yeah, but these are the smartest people telling you this, so then you're like, well, it must be true.
They must be smarter than us. So day to day, or do you find yourself mostly frustrated, mostly happy, or?
So it really depends on which stage of the project you are. If you ask me, the vast majority of the time is frustrating. Not in that sense of like, I'm going to kill myself. That's only every Friday. But overall, like right now, we're at the end of the project and pretty much everything fits. So like, it's okay. I can deal with it. But it's a project that's been running for 5 years. So 4.5 years was pretty bad.
So there is a light at the end of the tunnel.
Well, I'm leaving, so yeah.
There's a light for you. So what's your happiest memory from science, you think?
So from science per se, I mean, it was one of those very long days in the lab. It must have been, we started at 8 a.m., which is really early for me at least. And we were trying to isolate intestinal stem cells from humans, which had never been done at the time. This is early 2011. And
This is pre-Hans Cleaver's famous stuff, or?
yeah, so he did mouse, but with his technology, he couldn't do human. So in parallel to him, we developed a method that you could apply to humans, but we weren't sure if it would work. So after like 9 hours of experiments, my postdoc had already gone. I was running the test to see, and effectively. And on a Friday at 11:30 p.m., we had actually isolated human colon stem cells for the first time. That was a big rush. Then it took like 3 years to publish it. So after that, it was all like.
But so did you have to do it on like a live person? Did you have like a person there from 8 a.m. until
So,
11:30 p.m.
no.
like chilling? Or?
So, as far as I'm aware, the person's still alive. So we just got a tiny biopsy of a patient going a non-cancer related procedure. So they just looked into their intestines or colons, if you will, and they just grabbed a little sample and they sent this to us early in the morning. And then we had to just like, but the person themselves were not there.
Okay.
We try not to bring patients into the lab.
Do they know? Like, do people know when they're?
No.
Like, does
So-
this person has no idea? They could be in this audience right now, and they like would be like,
Now that
Like
you
if-
mention it, I did get a weird vibe when I got here.
like, oh wow,
But
you were
it's-
part of the greatest discovery I've ever made in science.
Yeah.
I know that small intestine.
Can we get a
I
look
could
inside
smell
of
it
you?
from a mile away.
Well, I think this is a good time. How about you explain to us a bit what you're studying, what you're interested in?
Okay, so basically I work in the interface between stem cells and cancer, mainly stem cells. And the reason we're interested in this very peculiar type of cells is because overall, when we're already adults, I'm just talking about adult stem cells, our tissues are constantly under stress. Depending the tissue, the more stress you have. So in my case, my liver would be under a constant stress, but for most people, it's actually skin, gut, the intestine, and the blood, which have to be renewed constantly. And this is achieved thanks to this small population of cells that are able to keep themselves in time and replenish these tissues.
So that's what makes a stem cell so special.
Exactly.
This
So-
ability to not only divide constantly, because most cells actually they're born and then they die,
Absolutely.
and then but a stem cell makes more of itself and then other types of cells. Is that right?
Exactly. So this is what we call the differentiation. So a stem cell will be able to keep itself going as a population, and then a subset of those will give their differentiated cells. So in the case of the skin, you have in your epidermal stem cells that then give rise to the cells that actually cover your skin. And upon damage, this usually gets like bumped up, turned up the notch, if you will, and then your tissue deals with it. So, well, how we keep homeostasis. The thing is that in the early 70s, now I'm going into the cancer bit, not we, I wasn't born at the time, but other scientists discovered that by mutating certain genes, you could like basically snap. You take a cell and convert it into something that goes insane and just never stops dividing. And that was like the ruling view of cancer. Is like, okay, we mutate something, this cell goes insane, starts multiplying, and then you have like a big chunk of crazy cells. And as years went by, this is absolutely true, but when you look at it closely, you realize that it's not like a chunk of cells that are like random, but it's very similar to where the tissue is. So if you get a blood cancer, it's very similar to how blood is organized. Or if you get a colon cancer, it's very similar to the colon. And what we thought at the time is that, well, maybe this structure that is so reminiscent to the normal tissue, maybe we have stem cells in the tumors. And this was shown for the first time in the mid-90s for leukemia, but we actually were the first ones to show it for colon cancer as well.
Your lab was.
Yeah. So
What lab is this, by the way?
Edouard Battier at IRB. So essentially, the concept behind this is like if stem cells regenerate our tissues, if we have cancer stem cells, they must regenerate the tumors. So if we find a way to target those little individuals, we might be able to, in a more effective way, get rid of tumors.
All right, and then so what in particular are you researching? At this moment.
So we
Give me the title of your latest paper.
For sure.
Yeah,
Okay,
for sure.
So it's entitled. Okay, everyone's sitting down, so it's good. X-ray labels intestinal stem cell subpopulation of slow proliferating cells that are resistant to therapy.
Was that a sentence?
We're working on it. It could be like the most awesome gene ever, but editors didn't like it.
Yeah.
So what we're doing right now is taking it into the next level. We know that there are normal stem cells in most tissues, and now apparently there are different types of stem cells in most tissues, which makes it a bit more complex. So in the gut, we found that we have very active stem cells and other ones that are slow. And these slow stem cells, which are slow for reasons we still don't understand, if you just give chemotherapy or radiotherapy, they just survive. And so if you're like a really hardcore stem cell aficionado, it's interesting. But what really matters is like if we could find that type of cell in tumors, this most likely is the culprit of resistance to chemotherapy. This is way out there. So this is the concept, but
Yeah, but this is the interesting thing. So let's talk a little bit about the stem cell niche in the gut.
Yep.
So I think probably this half of the room is from your side of the marriage, yeah?
yeah, pretty
So
much.
they know all this. But for those of you guys that don't know about how the gut is organized, and correct me if I'm wrong, but you think of it as a tube, and then if you look at the surface, the inside surface of the tube, there's what are called villi, yeah? There's these little protrusions of, it's epidermis?
Well, epithelium.
Epithelium. And they expose themselves to the stuff that you eat, and it allows your body to absorb nutrients through these cells, yeah? But now at the like intersection of two villi, you have a little pit. This is called the crypt, yeah?
Yes, sir.
And down at the bottom of the crypt is where your stem cells hide.
Yeah.
Don't look
It's
surprised.
the coolest name ever.
Yeah,
crypt?
I
The
work on
crypt.
crypts.
Yeah.
It's
Sneaky.
some real gangster.
Yeah,
Yeah.
it's like a
Stem
horror
cells.
movie. Like
The crypts in the villa.
All right. So as far as we know now, when a tumor arises in the gut, what cells are really kind of responsible for it?
So well, that's a good point. So the cell of origin is basically a stem cell. If you think about it, it makes sense. It's the population of cells that stays with us our entire lives. So if you mutate, put something like makes a cell crazy, but that cell will die in 3 days, you'll never get a tumor. But if you mutate something that stays with you throughout your life, the chances of that becoming a tumor increase. Now that has been proven in mice, not so much. Well, you cannot really do it in humans.
why not?
Well,
Because you can't like give
you'd
humans
have to
cancer.
induce. Yeah, well,
yeah.
yeah, exactly. So
Oh, but you can.
But you can do it to mice. You can just
yeah. So now the cell of origin, it's an interesting from the biological perspective. From the clinical perspective, when the patient goes to the clinic, the tumor's already there, so they don't really care at the clinical level where it came from. But we've realized that where it comes from, at least in the blood, we know it not always comes from stem cells, but different types of stem cells and so on, and this really determines how they are organized. So, I mean, for us biologists, it's great to know where it came from. For clinicians, it's like, how do I get rid of it?
Yeah, you said you don't run into patients often, right?
And ever.
Ever. I find it very difficult because sometimes, as a biologist, I get really excited about esoteric things, and it's like, oh, this is really, really neat. And you meet a parent of a child with cancer, and they're like, no, this fucking sucks. And so it's a tough line to cross or to walk, right?
Yeah. So, well,
When you talk about this stuff at the bar or anything, do you ever run up with somebody that's like, well, my nana, she's suffering right now. What can you do for her?
yeah, so essentially when I meet and we talk about this, so not in the scientific crowd, everyone knows how it is. Like, we're not really in touch with patients. I have no clinical background whatsoever. Yeah, I do find this, like, we're talking about, oh, what do you do? I treat cancer. And they're like, oh, wow. So is this new vitamin C therapy, blah, blah. It's like, probably not, but, like, my advice is always talk to your doctor, your clinician.
What's the most annoying question that you get about your research?
So why haven't you cured it yet?
Yeah.
We get that question a lot too
Actually,
at our show.
yeah. So you guys, I'm sure you're all aware because there was a scandal with Comics Curing Cancer program. And of course it was covered in TMZ, it was in the pages of the New York Times. But we had some commenters online who were asking, well, what foundation are you raising money for? And we had to say, like, first, we don't raise money. If you want to give us money, that's fine. But then we had to gently say that this is a science outreach program and that we're not actively curing cancer on stage. And they were upset. But
But we do have 2 people on stage right now who are actively working to cure cancer. So I think that's
Yeah, I was a bit
Not me,
offended. I
but-
was like, look, curing cancer is my day job. So
Yeah. So I just talk about it in the evenings as well.
yeah,
once
Well-
a week at least.
we don't have a life. That's okay.
We do now.
So to go back to your experiment, so if I get this right, you're trying to, using just normal cells, you're trying to identify which stem cells in the gut are more or less resistant to chemotherapies. Is that true?
So that's the goal right now. When we started the project, we had, as usual, a completely different idea in mind. I was analyzing this gene, and I thought this gene must be essential to keep stem cells as stem cells. So what we did is 3 years of work later, no, it's
Yeah, I was
doesn't
gonna
do
say, how
that.
did that work out?
Wonderfully, well, it's a good thing. As you know, this phrases they say, like, but you've learned so much, but you get nothing out of it. Well, that's exactly what happened. I learned a lot, but I got nothing out of it. So from that particular study that led nowhere and took me 3 years of my life,
You have a remarkably positive attitude about this.
well, because I do have something now. So if you had talked to me 3 years ago, I'd be like,
But do you find that, like, I find so many people that are in science, they have a project like that, and they're like, I'm gonna become a barista. That's fuck science.
yeah. So I tried that I'm not a good server.
Yeah.
So yeah, I just like, okay, I'll go back to my stem cells. So the objective of the project shifted because we went with the data. The data, I really had this huge model based on, this is how the system works in worms, like the ones Khaledi talked a couple of weeks ago. It's like, so it must be true in mice or humans. It's not the case at all. Then someone went and published that, and it's like, no, you liars.
Really?
Oh yeah.
What was their evidence? Can you describe this a little bit more? Feel free to go in details.
So essentially, I have this gene.
What's the gene?
MEX3A. If
Yeah,
you
fuck
go
that gene.
exactly, if you go to PubMed, you'll get 5 hits,
Yeah.
4 of which are lies.
Why do you say that? Can you?
No,
can you describe-
that's not fair. They're not lies. They may actually.
This is broadcast world over now, so
I'm sure
Remember-
one of the tens of millions is the author of that paper. I apologize. Your work may very well be true, but is not reflected by the biology of a normal mouse intestine.
So it's probably not true.
I have not said that.
Wait,
I'm saying it.
but this
I,
think-
stole your research.
But I think that these discrepancies, there's 2 lessons to be learned here, in my opinion. One is that a lot of non-scientists, they see something and look, not everything that's published is true forever and ever. Yeah, like a lot of times what a publication represents is like there is a person's best guess at what the world looks like. Like we did these things, and I think that happened because of this reason. As you know, as you said, like sometimes it's complete bullshit, but other times it's just it's a question of interpretation. So can you like in a general sense kind of identify what is different between what they did or think and what you are?
So
doing
the
it.
actual hypothesis is exactly the same one I had when I started the project. The major difference is how were we addressing it. So they did an in vitro approach, basically took advantage of cell lines.
Hold on, let's
Take
break it down. What's the hypothesis?
So the idea is there's this axis in C. elegans that is this protein called MEX3, which is the homologue of the gene I'm working with, that blocks the translation of PAL1, which is a transcription factor. So at the time, if you look at, I'm going way in depth here, but PAL1, the homologue of PAL1 is CDX2, and at the time we started this project, it was thought to be the main protein driving the differentiation of stem cells in the gut. So when we purified stem cells in human and mice and so on, we found that in these stem cells we had this gene called MEX3A, and then we knew the other bit of CDX2 that was the main driver of differentiation.
So the hypothesis is that MAX3 maintains a stem cell by blocking CDX2.
Exactly.
Okay.
And I tried this in all the cell lines I had available at the time, and there were some hints, but when you do it like thoroughly, there's nothing there.
So what you do is you delete or inhibit MAX2 to see if you raise CDX.
Exactly.
MAX3
And
raise CDX.
yeah. and that wasn't the case.
And then what did this group of like no-name ass monkeys?
So they did the other experiment, which is instead of removing the protein, they just put 100,000 times more, and then it happened.
What?
The blockade of CDH2.
I was gonna say nothing happened, right? The cells didn't differentiate.
In my hands, they didn't.
Yeah, but that's all right.
So it's well, the bottom line came when, after a couple of years of doing this and that, I actually made the cleanest system we have, and it's a knockout mouse of MEX3A in the intestine. You knock it out, completely remove the function, CDX2 unchanged, the gut completely unchanged, couldn't care less. So then we basically disprove that it's what they find is probably very specific to the cell line they used, which that cell line in particular, I didn't try.
Where was their work published?
NAR. It's not a bad paper, I just couldn't reproduce it.
Oh, well.
That sounds like bad science to me.
Oh, I don't know. You know what though? All right, like correct me. I feel. How does our audience of researchers feel? Because sometimes I feel like scientists are a little too polite, and we're very it's kind of like everybody's right. Oh, you published that? Oh, okay. It could be true. I think that we would be a little bit better off if we could all just be a little bit more aggressive. Now, there's like some like massive assholes out there, and of course, I'm not condoning that. But like, if you could just call bullshit on something, I don't know. Do you think that would?
Isn't that what
be
like
more
peer
fun?
reviewing means? That's what I always thought it meant. You like send to people and they're like, "This is shit, terrible."
Yeah, reviewer number 3 is always an asshole. That's true.
Well, it comes with a description. When you get a paper, the editor says, by the way, you're reviewer 3, so just step it up a notch. Yeah. So.
I always wondered how that worked.
Yeah, no, it's like that.
If you send a paper out for review, for publication, what happens is they send you back. Generally, they send your paper to 3 different scientists who read it and then give comments on it. Yeah, and you read it. Reviewer number 1 is ecstatic. They say this is like Nobel Prize worthy material. It's perfect. No changes.
Never happened.
Reviewer
to
number
me.
2, for you maybe. Reviewer number 2, they'll be like, well, this seems like a good thing, but I think that this and this experiment would strengthen the study. And then reviewer number 3 is always like, I don't even know why you even wake up in the morning. This is horrible. This is the worst thing that you could ever do.
I would be a great reviewer number 3. Just be like, this is awful, horrible.
Yeah,
Burn it.
I've
Every
always-
copy you have. Burn the hard drive of the computer.
I always wonder, like, when I review a paper, I try to not let my current mood affect that. So if my
It's very
experiment,
big of you.
my experiment just failed, I was like, I'll review this later.
So, I can't believe that. Me, if I don't have my coffee, you can just count on it. I reject it. No, that's not true.
He rejects it with coffee as well.
Yeah. You gotta reject it on the first pass anyway. Make them work for it. No, so your research. So you find out that MAX3 does not affect CDX2 levels nor the stemness in a mouse.
Yep.
So how did that lead you then to studying chemotherapies?
Well, we realized that, because we do mouse stuff, we made another mouse model. Just like, well, that didn't work, let's make another one. It's like, yeah,
Because
sure.
that's easy enough, right?
Yeah, it's a couple of years of your life, it's fine. So if you're going to
What
do
do you mean by making a mouse model? What is?
I'm playing God. No, so
Actually, this is really cool stuff. And no, it's not making sexy mice.
Yeah, that's sort of what I was in my head thinking, like
Oh.
Sports Illustrated mouse edition. Like, the rookies this year are mouse.
Playmate, mouse of the year.
So conceptually, what we actually do is so as I mentioned, we work with adult stem cells, which are the ones that keep the body functioning. Mouse have them, of course. And we also have embryonic stem cells, which are the cells that specify from one cell to the full organism. So a very bunch of very clever people, there's actually a Nobel Prize from a couple of years ago, discovered how to keep those cells in a dish. So this allows us to modify them. And then if you make a mouse out of that, it will have whatever you incorporated. Sounds crazy.
Sounds nuts. You just like grow a mouse from a petri dish, like.
Well, no.
What is
you,
like how like I'm.
Na-
It's
nature
mouse
takes
starter
over.
culture, right? So it's like sperm and egg meet, right?
Mhm.
And they create what's
And then
called
you
a
put it in
zygote.
another mouse, and it makes.
You
mouse
take that,
babies.
you let it bake in a
Oh,
dish
okay.
for a little bit, and then you can make genetic modifications to that, and then stick that back
into a mama mouse.
Yeah.
well into embryo into
Okay.
a mama
Into
mouse.
mama
Yeah.
mouse.
Oh, okay.
And then
And then-
lo and behold, you get baby mice with
Wow. That are like exactly a certain way that you want them
Exactly.
to be.
Well, if
Okay.
you do it properly, yes. If not, it's very
Dude.
long, tedious.
That's
and-
like
So when we work with autistic mice, like I think it's a fascinating ethical question because you can create a retarded mouse or
Hey, yeah. don't say that
autistic.
word.
No offense, but I'm sorry. But no, like when somebody is born with like a severe defect, you just say, that's life. When you can create that defect then in an animal, I don't know if that's cruel or I mean we try to raise these animals as gently as possible.
Yeah, it's probably cruel, but who cares
But then,
about mice?
but then we
I
try to
mean,
fix it, so it's okay.
Yeah.
Oh yeah, no. The cancer field
But
is
how
full
many? Okay, how many mice have both of you guys killed? Like this is
of.
in your
4.
lifetime.
In my lifetime.
You probably a lot.
Yeah.
You look like a mouse murderer. I can see it in your eyes. there.
Actually, me myself, I don't do that.
No, you don't touch the mice.
No, we have a very skilled veterinary that he takes care of it. So we know the mice are well taken care of. It's a big issue for me. I'm not a big fan of mouse work, but I think it's important enough that I do it.
Yeah.
I think like the
I mean, it's better than
advances-
doing stuff on humans because that'd be like terrifying.
Yeah, and well, so if you have concerns about making weird mice and making
Yeah.
weird humans, so
No, that's totally cool. All my children are fucked up.
so then so we made this other mouse for MEX3A that instead of deleting the function of the protein, we can actually see where it's expressed. And I thought it would be expressed in every stem cell because that's where we found the gene. But it's actually not expressed in every stem cell, but a subset of these. And then when you start digging a bit deeper, and by digging a bit deeper, it's like analyzing a lot of mice and spending 4 years more doing that. I do it in parallel. It's not like I did 3 years and then 4 and then 5. So,
So you don't look like you're like 78.
no, like
Don't
55.
be. That's not fair.
Yeah, so
But
then
can I ask so when you say it's not that, it's a subset of stem cells,
Yeah.
but like to go back to the crypt analogy, there's like the little tiny LGR5 positive stem cell, and then it's sandwiched between Paneth cells. Is
Yeah.
that right? So where is this expressed?
So, wow. Okay, I never thought we'd reach this level of depth. This is really for like even people in my lab fall asleep when I talk about this. So,
Are you guys falling asleep?
See some.
Okay.
We can talk about sex. So what's the most awkward thing you've done with? No.
dude, I wasn't kidding about the black belt.
Then I won't tell you the most awkward thing I did with your.
Oh.
Oh,
Trying to stir the pot.
yeah.
Keep you
All right.
on your toes,
Okay,
guys. Keep you on your
so-
toes.
You're right. So the LGR5 cells are wedged between these differentiated cells, and this is the stem cell niche. So what we find is that this is basically almost leaving the niche. So it's like in the interface. This is kind of cool because in the early 70s, they already described that these type of cells existed, but no one's been able to actually identify them properly. And we have like probably 15 other groups working in different ways to see that. And what we've actually found is quite unique in that everyone else claims it's a completely different subset of stem cells, but we actually find it's one of a subset of the LGR5. Again, if you work on this, it's interesting.
So for the people that don't work on it though, when you now have this mouse model, and you're able to label a specific type of gut stem cell, yeah, and you believe this gut stem cell then leads to cancer sometimes. You're giving these mice chemotherapies that tend to kill everything, and this one remains, or what happens?
So we haven't got into the cancer bit yet. So I have some preliminary data that's not on the current paper that these subpopulation may exist in mouse tumors. What we've tried to understand is how the gut regenerates. It's so fast-paced that actually when you see like patients that receive chemotherapy, what they do is that they get anemic because they have issues with the blood. They get bald because of issues with the hair follicle, or in my case, just being bald. And you also have issues eating because your intestinal epithelium is really messed up. You cannot really absorb any nutrients, and people have a lot of diarrhea and so on. So the early studies is like, if you destroy up to 95% of the gut, in 2 weeks it's completely regenerated. So you can give total body radiation to mice, almost wipe out every stem cell. If you do all of them, it's bad, but if you just leave 5% of those, it's enough to repopulate. And we weren't really understanding how these very fast stem cells are actually able to regenerate after damage. And this population could in part be that, responsible for that. So in that sense, it's interesting.
So they're different kinds of stem cells. They're like not just for different parts of your body, but like that act differently is what.
Yeah, absolutely. So every tissue, as far as we've been able to see, has at least one type of stem cell, and most of them, when you look in depth, have several types of stem cells.
And so some of them are super fast.
Yeah. So it really correlates with how much damage the tissue's getting. So muscle has stem cells, but they're very quiet. They don't do much unless you either get a muscle injury and then they are activated to regenerate, or you start like pumping iron like crazy and you want to bulk up, then you really need to activate those stem cells. So in the brain, you also have several types of stem cells, one that give rise to your olfactory epithelium, that regenerate also some of your neurons. This was very controversial for many years, but now we know. One of the cool things about MEX is that it not only labels stem cells in the gut, but it pretty much every other tissue we've looked at.
It's stem cells throughout, though.
Yeah, there's very few genes that do that, actually. So we have like a bunch of collaborations right now looking into that.
And it's all in post-transcriptional, or it has its role is always post-transcriptional.
As far as we can tell, yeah. But we don't know much of what it's doing. It's doing too many things for us to really
Is it
pinpoint.
signaling protein or a kinase?
No,
or
it's RNA binding.
Oh, shit.
Yeah.
I don't mess with RNA.
No,
Nobody else cares. But
it's a
I'm just
message
saying,
for all you
that
kids
shit's
out
scary.
there. Don't work with RNA binding proteins.
Yeah.
Not even once, guys.
So what do you think are the major unresolved questions left? Well, for your work in particular.
So the idea of cancer stem cells is neat. Is that, oh yeah, if we find a way to really destroy stem cells in a tumor, then the tumor will collapse. No one's ever shown this conclusively. Well, we have some types of models in subtypes of leukemia, but it's not in solid tumors. It's not really known. You can show that cancer stem cells exist with some assays, but we still to this day don't know if it'll have any clinical value.
So the whole field of everybody that's chasing this this magic bullet, so to speak, that will kill the cancer stem cell, we don't even know that even if you can accomplish that, if that will work in curing cancer.
Absolutely. So there's some data.
Tell that to the guy that yelled at me for not curing cancer.
Again,
Stuff's
it's
hard.
when people ask you, so what's taking you so long? Yeah, no, it's so easy. I'm lazy.
I once, just completely randomly, before I went to graduate school, I worked as a garbage man. Yeah? As you do with
As
2
you
degrees
do.
in biochemistry. And the guys really liked me, slinging trash, and they were like, Matt, you should not go to graduate school. I was like, guys, no, I think I should. I happen to be good at science, and I think I can make the world a little bit better. This guy was like, no, Matt, look, they have a cure for cancer. The pharmaceutical companies, they have it. They just, they don't want to release it because then they won't be able to sell drugs. So, that's
Well, now that you mentioned,
that's why you don't take medical advice from garbage men, but...
Yeah, so my take on that is anytime I read about this magic conspiracy about pharma hiding things, it's like, have you ever been to a cancer ward? Do you think like the doctors seeing their patients be like, sorry, we have it in the drawer, but no.
Yeah, that's
so there's
actually a great
people
point.
dying there, and the doctors are not like robots giving drugs. They really care about their patients. So every time I hear this argument, it's like, no, it's a big pharma. I'm not saying that pharma is great, but if we had access to that, if that actually existed, people would like well, they'll make a lot of money out of it, so I'm
You
sure
think
they would sell
they
it.
wouldn't mess with cancer? They wouldn't go that far. They'll mess with like nut allergies and like other
So
stuff.
It would just require a lot of people to be really crappy people.
I
Yeah, I
mean,
for a very long time. So I've heard this. So the cure of cancer has been hiding since I started
in Area
studying
51,
cancer.
right?
Yeah.
So just to wrap up then, like where is your career headed? What's the next step for you? You said that you're leaving this project?
I am leaving this project finally, and whoever, people in my lab are clapping about that.
They look really happy.
They're so excited you're leaving.
Yeah. So right now I'm wrapping this up, and by January we're moving with my wife to New York and starting another postdoc.
Yeah, New York is
So-
very dear to the both of us.
Oh, right.
She
Yeah.
grew up like an hour north, say,
Well, yeah,
of
45
New York
minutes
City.
north.
The Hamptons,
No, the other direction, Westchester County, man. Terrytown.
Terrytown.
Hudson River Valley.
I have
Killing
no
it.
idea
It's
what you're
beautiful.
saying.
My
It's
grandfather
beautiful
is
there.
buried in
You should go visit.
Tarrytown.
Go on a day trip. Go on a day trip up the Hudson River. Go to my town. Do a lot of antiquing. It's great.
Darling,
nice.
it's fabulous.
My-
You're gonna love it.
Yeah, my town is like the new Brooklyn. It's like full of hipster, or it's like it's getting super hipster and cool.
Because Brooklyn is too expensive.
Exactly.
Yeah.
Because it used to be Brooklyn was where all like the hipsters went, and now they go to Westchester. Because now there's cool towns. There's cool little river towns.
Ah, good to know. I'll let my
Check
beard
it out.
grow.
Yeah.
So then, yeah, we're moving to New York, and we're going to I'm going to Memorial Sloan Kettering to work on more cancer.
Which is really impressive. It's one of the most world-renowned cancer centers. Best of luck to you.
Yeah,
Thank
man.
you. So you see,
Great.
anyone can make it.
If this guy can do it, he's only brilliant. No, yeah, let me thank you for coming on the show tonight.
Oh,
Yeah,
thank you
thanks
for
so
having
much.
me. I'll be here every Monday, as you know.
Fantastic. Speaking of which, so that's going to be it for us tonight. Tune in every Monday. Like us on Facebook. I hear that helps somebody somehow. I don't know.
Children in Africa.
Children, people with cancer. Like us on Facebook. Next week we have our guest will be studying binary stars. So we'll be talking astronomy.
Astronomy,
Yeah.
not astrology. Who's the scientist up here, Matt?
I start studying for next week's show tomorrow. Yeah, no, but please do like us on Facebook. Come back next Monday, same time, same place. Do you guys have any questions?
No, any questions for our wonderful guest over here? No? You can come up. You have a question?
So much for my great
I'm sorry.
extra.
So George W. Bush and many others were against stem cell research.
Yes.
Right? To what extent did that affect research in the States and actually make it more interesting in other places?
Okay, so I've never worked in the States. I have read extensively about this because I do work on stem cells. That actually stopped a lot of things going on. So you would notice that induced pluripotent stem cells, which was one of the major breakthroughs of the last 10 years, was actually developed in Japan. So maybe that had something to do with it. Probably not. We don't really know. What is clear is that blocking research at any level will lead to unexpected consequences. We don't really know where the revolutions come from. So the classic case is cisplatin. Cisplatin is the forefront drug in most cancer treatments. And this was discovered by a man studying the effect of electromagnetic fields on bacterial growth. So that guy at this day with that proposal will never get a grant. So I would say that he probably affected research in ways we really don't know. It opened up a lot of venues in Europe and in Japan for stem cell research, so I'm guessing that brought a lot of talent to those places. So yeah, I mean, I would say science for everyone and more money, please. Yeah?
Yeah, the message is stem cells are good. Yeah,
Pretty much.
yeah,
They keep us alive.
I like them. Any other questions? No? All right, so tune in, folks. Next week, same time, same channel. Watch some comics cure cancer. Write better
something.
jokes.
Jokes. Yeah.
Yeah. That'll be good. Thank you very much.
Yeah, tell your friends, like us on Facebook.
Let's hear it for Francisco Berriga, my co-host Anna Becker, sound man Carlos Charms,
Carlos, woo!
whole staff.
There she goes again.
Thank you.
Thanks.
Tidied up.
Stay tuned for our comedy show.
All my tunes and wires, careful notes. Antiquated notions. Poetry in motion.
Yeah. I just want. Also, there's going to be a pure stand-up comedy show after this too. We're going to take a 15-minute break, come back for some laughs, some real laughs, real professionals. Thank you.